Welcome to Học tiếng Anh với Joseph, where we build vocabulary and practice pronunciation through reading. Continue with The Cat in the Box, story number 34, The Death of Vitalism. This is a more dense story involving more people. So let's start it. The idea of a special life force that operated in the chemistry of living things but not in the chemistry of non-living things took a long time to die. But a key step down that road was taken accidentally in 1828 when the German chemist Friedrich Wöhler found that it is possible to make at least some organic compounds which had previously been assumed to be produced only by living things in the proverbial test tube. Back in 1773, the French scientist Hilaire Rouelle had isolated crystals of a substance that became known as urea from the urine of various animals, including people. This was already something of a puzzle for proponents of vitalism, as urea turned out to be a relatively simple compound. In modern notation, it is H2N, CO, and H2, which hardly seem complicated enough to require the influence of a life force in its manufacture. Nevertheless, Wöhler was, like most of his contemporaries, a confirmed vitalist when he set out on a course of experiments in which he was trying to make ammonium cyanide. By reacting ammonium chloride with silver cyanate. To his surprise, the crystals produced by the reaction were the same as the ones Rouelle had found. Urea. A molecule of ammonium cyanide does actually contain the same atoms as a molecule of urea, but in a different geometrical arrangement. Wöhler wrote to Berzelius that he could make urea without the use of kidneys, either man or dog. But he was not happy with the discovery and told Berzelius that the great tragedy of science is the slaying of a beautiful hypothesis by an ugly fact. Yet again, if it disagrees with experiment, then it is wrong. This was not, however, the end of vitalism. Urea is a relatively simple organic substance, so perhaps it might be a special case. Many other, more complex compounds still could not be manufactured except by living organisms, and there was widespread resistance to the idea that there was no need for a life force until well into the 1840s. In 1845, however, another German, Adolf Kolbe, deliberately set out to establish that organic compounds could be made from inorganic substances by converting carbon disulfide into acetic acid. As the carbon disulfide itself is easily made out of its constituent parts, the whole process involved a series of chemical steps known as a total synthesis. This is the complete synthesis of an organic compound from simple precursors without involving any biological processes. The great champion of total synthesis in the mid-19th century was the Parisian Marcellin Berthelot. In 1855, he synthesized ethyl alcohol from ethylene, Previously, ethyl alcohol had been prepared by fermenting sugars with yeast, a biological process. But ethylene is an inorganic molecule. Berthelot convinced himself that all organic compounds could be manufactured from inorganic substances by a careful process of total synthesis. So he set out on an ambitious program to synthesize every known organic substance by starting out from simple inorganic substances and building up more and more complicated compounds step by step. He planned to move up from simple hydrocarbons like methane to alcohol, which contain an OH group, esters, in which an OH group is replaced by a more complex alkoxy group, organic acids, which contain even more complex groups, and so on. His successes included the synthesis of formic acid, the chemical that ants used to sting with, acetylene, by passing an electric arc like the one invented by Humphrey Davy between carbon electrodes in an atmosphere of hydrogen, and benzene by heating acetylene in the glass tube. The synthesis of benzene was particularly significant because each molecule contains 6 carbon atoms joined in a ring. It occurred naturally in crude oil, the remains of living organisms. But by synthesizing it, Berthelot opened a new branch of chemistry involving the reactions of such ring molecules, now known as aromatics. Unlike Wohler, Berthelot was an almost evangelical proponent of the idea that all chemical processes are based on the action of physical forces that can be studied and measured, like the forces involved in mechanical processes. His grand program of photosynthesis was far too ambitious for one man to complete, but he did enough to show that it is indeed possible to create organic substances from the 4 elements found in all living things: carbon, hydrogen, oxygen, and nitrogen, collectively referred to as CHON, CHON. When his definitive work on the synthesis of organic chemicals, Chimie organique fondée sur la synthèse, Organic Chemistry Founded on Synthesis, was published in 1860, it sounded the death knell of vitalism. To the vocabulary section, there are more words in this section than the previous one. Vitalism, vital, vitalism. Accident, accidentally, accidental. Nevertheless, same as nonetheless, nevertheless. Contemporaries, contemporaries. Complex compounds, complex compound, complex compounds. Widespread resistance, widespread resistance. Living organisms, living organisms. Constituent parts, constituents parts, constituents parts. Precursors, precursors. Synthesis, synthesize, synthesizing. Synthesis, synthesize. Ambition, ambitious, ambitious. Aromatics, aroma, aromatics. Sounded the death knell, sounded the death knell. I know it is very, very difficult to pronounce them, all of these words, but you just keep doing it, you will get better and things will get easier. So as always, thank you for your time, and I will see you tomorrow in the next story. Bye for now.